Nice one. Okay, so appreciate it, guys. The weather was just looking a bit awful tonight, so I've given you the option of Zoom, which quite a few of you have taken up, so that's brilliant. Okay. Any issues with sound, any issues with me sharing the screen, give me a wee shout, okay? And I'll try and notice. All right, which is easier said than done sometimes. But please shout out if there's any issues. What I want to cover tonight is a couple of things. We're going to do something called functional notation. Now, functional notation is just another way that we can write out formula, all right, or equations. Okay, so it's just a wee reformatting of it. And then there's two types of questions that can come up using that. They're not big markers, but they're good wee ones to. They usually start off the paper with them and stuff like that. All right, so they're nice ones to get your teeth into. We don't go deep into functional notation. You use it a lot more once you go up the levels and higher and stuff. So this is probably the first and last you might see a functional notation. But again, couple of marks in the exam, knock it out, move on. All right, so it's some nice questions. Okay, so functional notation. Following that, we're going to move into our sort of monthly recap of rearranging equations. Okay, so this will sort of be the last time to cover this in any particular depth. Okay, but we'll be going over the exam style questions where you have to rearrange equations, you need to transpose equations. Okay, so functional notation. Notation. Okay. Usually a two marker, something along those lines. Functional notation is a different way right the equations that we're familiar with. So for straight line, for example, we've been using y equals mx plus c. Okay. That's the sort of algebraic method. There's another form of math that you don't need to know the in-depth of, but there's another form called calculus. All right, and they like to write it in functions. So instead of the y, we'll write it as a function of x. All right, so a function of the variable x equals mx plus c. All right, so if you put some numbers in that, you can have something like y equals 2x plus 9, or a function of x equals 2x plus 9. They mean the exact same thing. Okay? They mean the exact same thing. The fx part just means that the function f is true for the value given the value for the variable in the bracket. True if the value given in the bracket. Okay, so there's two types of ways they can give you this question. All right, I'm maybe going a little bit fast there. This will make more sense once we start putting numbers into it. All right. One way they can ask you is they give you the function with a value inside the bracket. Okay. That means we are substituting the number inside the bracket into an equation. We just place we're replacing the letter. Okay. Instead of the letter X on the right hand side, we'd replace the letter X, every letter X there with that number 3. All right. This is called an input question. Second type of question. Okay. When we've got F in the letter variable and it equals to something, that means we are looking to solve the equation to find the number we would replace the letter X with. To give us the solution. All right. That number 4 is the solution. All right, that's the answer. That's the answer to the question. That's the answer to the function. So what are we putting in place of X to find out the number 4 to give us the answer? All right. This is an output question. One of the parts of this question, you don't get a mark for it per se, all right? Your marks come from solving it. But one of the things you need to know is what type of question you're actually trying to answer. Is it an input or an output? All right, sometimes they're really obvious, hopefully. Okay. Give an example. Function fx equals 6x minus 4. Find the following. Okay. We get something like that, or simply, if you got that in an exam, your answer would just be write out the equation again, 6x minus 4, then what they've given you there. Now, everywhere you see an X, you're putting that number. So this is an input question. All right. Simple as that. Okay, so that's an input question. We're inputting, where we see that letter, we're inputting that number. All right. The same function. Okay. Yes, these are all input questions. We're inputting that number in the bracket. Yeah, if I pull the screen away too quickly, or you want me to just clarify something, give me a wee shout. Same function. Okay, but this time we're going to do output questions. Okay, that's an output question. So, what will the value what value of x give us the answer 8? Okay, so for this one, we're setting the equation equal to our solution. Okay, so right now it's slightly different with that. So we're now solving for x, okay, like we did a lot of the times when we were finding the x value, the x coordinate, when we were doing this for the straight lines. Okay, so we're just doing our transposition. Okay, so we're moving everything away from it. Remember, the add and subtracts are moved first. 6x, 8 minus 1 plus 4, 6x, 12. Okay, and that would be your answer. So to find that value, to find the number 8, we have to put in x equals 2. So if we put that in now, we do a wee check. You don't need to do this in the exam. Okay. Yeah, it's just a wee check. Okay, and you should get the original value for that function. Okay. A couple more examples. Just using that exact same function.
Daniel, sorry to interrupt. See
What?
how in the exam, would they give you like a sort of I don't know, like a story or something like that with those kind of figures in it, or would it just be as simple as like the FX thing?
9 times out of 10, it's as simple as the FX thing.
Right, okay.
Really, it's a 2-marker, nice simple question, just to get you the ball rolling in the exam.
Okay, cool. Thanks.
Watch this year will be a big question.
If it is, I'm coming back to you.
People do. I'll be standing outside the exam. Alright, so just rearranging that, x equals minus 3. Okay. Last week's example using this one. It's the exact same. Right. Lovely. Alright, and again, if you've got time in the exam, just give it a wee check. Alright. We'll do them just one way that I like to throw in sometimes. This is another example. Alright. We'll sometimes throw in an input question, an input a 0. Okay. Don't be thrown off with that. Anything multiplied by 0 is just 0. Okay. Or they might give you an output question, okay, but they'll give you a function in x, but then say for value of t or another letter, okay, we give you -4. All right. Now, what that's meant to show is you can put multiple things in there, multiple numbers, multiple different options can go into that equation, okay, but it's still in the same format. All right, so ft, they're just substituting in the t instead of the x, okay, it will still be, okay, so it's in the exact same format except to the x, I'm using the t there, okay.
Can I just ask quickly where you're getting like the 12 and stuff from? Like I get the basis of it, but I don't know where like I don't get the step by steps, like each bit. Does that make sense?
Moving the stuff across.
Yeah, so like obviously I get the basis of the input and the output, but I'm not really getting like the step by step of what would actually happen next.
So that's
Yeah, like where did you get the 4t plus 12 thing from?
Yeah.
that's just this equation, but instead of the x, I'm using the letter t.
Oh, okay.
All right, so they might just ask it in a slightly, so they'll give you for function fx equals 4x plus 12. FP equal to 10. All right, then it will ask you to work that out. So it'd be 4p plus 12 equals 10. It's just a different way of doing the output. All right.
Right. So would you get the two first lines in? See the bit that's fx and
Yeah.
the FP, would you get those two lines in?
Yeah, you get given then.
Oh, right, okay.
All right.
Yeah.
So you get given in the queue, given in the question. All right. N minus 12. Right, I'll actually give you some past papers questions on it then. So 2019 past paper. Question 1, all right, paper 1, so that's the first question. You were given fx equals 5x cubed. Evaluate, spell that correctly. Evaluate. All right, that'll be the question. All right, so remember the way that we carry out each operation, we just follow BODMAS. All right, so is there any brackets and orders that we need to do? Yep, there's a wee order there. So we do the -2 cubed first. All right, so we carry out the -2 cubed, that's the first action we're doing. So -2 cubed is just -2 times -2 times -2. All right, that's all the cubed part is. Okay, so -2 times -2 is +4. We still need to times that again by -2. So your overall or final answer would be -8. Okay, so you'd be 5 times -8. Okay, so feel free to do something like that over in a different side of your paper. Or just put a wee box around it just so you know it's part of your working. Okay, you don't need to do that to get the correct answer. Remember, that's only a wee 2-mark question. You get a mark knowing that you had to substitute it in. And then you get a mark for the final answer. All right, so just a wee 2-mark question. Okay, so remember.
Would you divide the -40 by the -2? No.
No. No.
No. Okay.
So you're thinking of an output question.
Ah, okay. Right, okay.
So that's input. So we're inputting whatever's in the bracket. Okay, so that stays. So what is the solution of the function when x equals -2? Now, if they asked that an output question, then you would have had f x equals x cubed. What did it said? Calculate. Okay, that's an output question. So
Right, I
FM,
see what you mean. I see what you
Right.
mean.
so this time we're trying to find what we'd put in the bracket, and
Yep.
that would mean, oops. Which is slightly harder. Oh. And we cover this, so this is quite a difficult transposition. All right, this is difficult rearranging. We cover this later tonight, by the way. All right, so don't worry too much if you're like, what the hell just happened there? Okay, we'll cover that again. Okay. So in 2018, it was an output question. All right. And it was given. This is the one where they changed the letter. Okay. All right, so they changed the letter for some reason. All right, so that, what they wanted you to do is rewrite it essentially.
That's having cubed.
No, 73. That's that. All right, so that function equals 73. So you have 5 plus 4a equals 73. 4a equals 73 minus 5. 15, 17. Randomly, that was in the calculator paper, but okay. So a wee bit of
Should you
more-
just, sorry, should you just ignore like the letter change? Like that won't affect anything?
Yeah, so
Okay,
you're exactly right. So they're just, yeah, easy. Yeah, I don't know why they're changing the letter there. but
okay.
Just a different way of input.
Also, see, sometimes they try and throw you off slightly with like the calculator paper. 'Cause I felt as if, like, see that unit one, if it was with the calculator paper, some of them like weren't like calculators to do that in the actual exam, or sometimes your actual question marks calculator.
All right.
Yeah.
Yeah,
Right. Okay.
you would have. You could have done that in a non-calc, no problem.
Yeah.
Okay, and then 2016. Let's have a wee look at 2016. And this is the reason why I had you look at sorts at the start. So this is paper 1, version 9. Okay. And the question was express as a fraction. So it's rare that they mix this type of question up, all right? But in 2016, they put this in with a surd. So they're looking for you to rationalize the denominator and understand that it's a functional notation. Okay, so the function when x is equal to 5, look at that. Okay, now we want to rewrite that as a rational denominator. That just means we're taking the surd away from the bottom. All right, to do that, nothing changes. In our process, just multiply the top and the bottom by root 5. And root 5 times root 5 will just give us positive integer of 5. Okay, so that was the final answer. That's a fraction and it's got a rational denominator, and you've known to put the number 5 in place of the x. All right. Let's try this. All right. These are we trying.
What's that last one? F what?
FR.
Okay.
So finding the letter R. Okay, something that we've looked at, we sort of look at through every stage. And I like to go back every now and again and just go, right, this is what we do and just refresh ourselves. And it's just changing the subject of a formula. All right, so we've done it in volume, we've done it in algebra. We do it everywhere. Now, there are specific questions where you will get asked to change the subject of a formula. So that's what we're going to cover tonight, all right, the way that they type it out. But there's no different to some of the stuff we've done. All right, a formula is just used to calculate a sort of real life value. We've used them when we're doing volumes. All right, volume of the cylinder, we've used them for R. All right. In the exam, you'll get given, sometimes there'll be ones that exist. All right, that's a physics equation. For sort of distance displacements. All right, you don't need to know that. All right, but just know that these ones are out there, these formulas are out there. You might get asked to rearrange them. All right, or you might get something, another sort of physicsy ones for velocity. You might get asked to rearrange these, all right? So it's just a physics one for velocity. All right, we just need to get strong at rewriting these and be comfortable rewriting these and rearranging to find different variables in it. All right, so in volume we changed it to find height. In R we used some of them and we had to find the radius and sometimes. But in the exam you'll get given an equation that usually exists. All right, but they just might make some up and throw some letters at you. All right. Methods. Usually, you'll be given an equation, left-hand side and right-hand side, and the variable that they ask you to rearrange for is on the right-hand side. Okay, so that's all right. So when I do that up until now, we've just sort of been doing it and I've been explaining as I've done it. All right, but let's just write that down. If the variable you're looking for is on the right-hand side, flip that equation round. All right, so it's on the left-hand side. That means it will be your variable you're looking for, such as x equals, and then the rest of it. All right, so you're isolating it. You're looking to isolate that variable. Two, the order in which we move things is important. All right, the first things we're looking to do is move the pluses and minuses. Second thing is our multiples. Third, so our powers. All right, but watch out for our barriers. All right, barriers are our root signs. Barriers are our brackets, and the barriers are our fractions. All right. Now I like to say sort of reverse BODMAS. All right, so when we're reversing BODMAS is how we work out the function. All right, and reversing it. Okay, Sam Dobb. All right, our add and subtracts move first. Okay, our multiples and divides move second, and then these are the sort of barriers that we're sort of moving last. All right, it's not a perfect function, but it sort of rings true in my head when we're doing it. Okay. It's just knowing when to move something across and just getting comfortable with it. So let's just do a couple of examples, Now, the way they'll be written in the exam, the variable in the bracket, the wee square brackets like that, the subject of the formula. All right, so we've seen it plenty of times. Straight line, okay. And a wee square brackets with the x in it. That just means we're isolating x. All right, so what would x be isolated? All right, so rearranging that, making the subject of the formula whatever's in the bracket. So in this case, x. Okay, that first step, I want x on the left-hand side. It just makes me stay consistent. So literally just flip it round and don't do anything to any of the signs or any of the sort of positions of the layout. Okay, that's just step one. Okay, I've just flipped it round, I've just turned it round. Just think of it as a seesaw. All right, the left-hand side and the right-hand side of the seesaw, if it's perfectly balanced, all right, you can turn that around 180 degrees and it will still be perfectly balanced if you never moved anything. Once you start moving stuff, all right, you need to do the same to both sides to keep that balance. Okay, so just switch it round like that. 6x plus 9 equals y. And then what are we moving first? The addition in this case moves before the multiplication. So we're moving that plus 9 before we move the 6x part. Positive on the left-hand side becomes negative on the right. And then we're moving the 6 to isolate the x. Okay, to remove the 6 from the left, it's a multiple. So it becomes a divide on the right, but be very careful, it needs to divide the whole right-hand side. Okay. As I said, they'll use unconventional letters when this is just a question like this. So don't be thrown off. Remember, these letters are just a place where we can put a number. All right. So flip it around. Five t plus d equals z. All right, treat them like you would treat a number. All right, so that positive d just becomes a negative on the other side. 5 just becomes a divide. We're dividing that whole right-hand side. All right, this is just about practice, just making sure that we're on top of it. If at any point I go too fast, if you want me to go over something, give me a wee shout. As v equals u plus at, want to rearrange, I want to transpose to make the subject of the formula T. Flip it round. Move over. Get everything that's not beside the T away, okay, so that addition. Move it across. Okay. P equals 4RT minus 2M. Flip it round. Okay, want to isolate the R. First thing I'm going to move is that minus 2M. Okay, first thing I'm going to move is that minus 2M across. Now, I'm moving that whole thing, so even though it means minus 2 multiplied by M, okay, I'm moving that as a whole, okay? So that minus 2M becomes positive 2M at the other side. Okay. At this point, I can move them individually, okay? So it's 4 times R times T. Okay, so if I'm moving a multiple on the left-hand side, it becomes a divide over on the right-hand side. Now I can move the 4 and the T together, okay, or I can, if it's perfectly fine if you do it individually in the exam. All right, moving them together to isolate R. They both go over to the other side, okay, but it becomes a divide. T equals 5M minus 3PB, making the subject of the formula B. All right, spin it around. Nothing happens to it, it means the exact same. Okay, but now the B is over on the left-hand side. Okay, now what might throw you is that negative sign. Okay, but don't bother with that, we'll do it right at the end. Okay, but we're moving that 5M across. And we're leaving that negative 3PB. To leave us that. Okay. Now that negative 3 times P times B. Okay, I want to remove the negative 3 in the P. Okay, so that negative 3 in the P is multiplied by that B. So when I'm moving that across, that negative 3P becomes a divide. The negative stays where it is. Sorry, the negative comes over, and it just becomes a negative. Okay, let's try a few of these yourselves. Making the bracketed term the subject of the formula, okay? First one, you should be okay with. Spread that out. Okay, rearranging that, try to find X. Again, we're thinking about it in order. Okay, is there any add and subtracts? Yes, but there's a barrier. Remember the barriers that we're looking out for. So we can't move that add or subtract first because it's involved in a fraction. So we need to take care of that fraction first before we deal with that add or subtract. Okay, so dealing with, spinning it around first. Keep it consistent. Okay, then we deal with a fraction first. So we're dealing with that barrier. Remember, fractions, root signs, or brackets we need to deal with. Okay, if they have to be dealt with before we move the addition sign. So that t moves across, becomes a multiple. Then we deal with the addition, becomes a minus. Then we deal with the multiple. And it's dividing the whole thing. MT or TM, no. Just like if you had 2 times 3 equals 6, 3 times 3 equals 6. So it doesn't matter. Isolating V, spin it around. Very similar to the last one we did. That A has to be moved first. The U gets moved across, becomes a positive. And the square term becomes a root.
What's the date of the prelim again?
The left field. Came from nowhere. It was 2 weeks before Easter, which is something like the 18th of March.
Okay,
Something along those lines, 2 weeks before Easter.
okay.
The week beginning 18th of March, so 19th or 21st. No, back in. Back in all of that. We'll finish the course by then, but the rest of the time will be revision. Yeah. half t minus 4p. Okay, another way to write that would be just t over 2, might be easier. Okay, then we need to deal with that addition first. Okay, we're moving that as a whole. Okay, because we're moving everything. Okay, it stays as a 4p. The divide on the left hand side becomes a multiple on the right hand side. Now I need to multiply that whole thing. Okay, so I use bracket. Everything over on the right hand side gets multiplied by that too. Oops. I'm gonna keep going, just gonna let me try that. One more time, a wee bit.
Can you break the brackets as like your final thingy, your final answer?
Yes, but you don't have to, you get full marks for that. Like that.
Right. Yeah.
Yeah, you don't have to. Actually, the simplest form would be with the bracket.
Okay, cool.
But if you did that, you'd be fine.
Okay.
Okay, so changing the subject. Going to combine a few things, okay? So this is where we're working with barriers. Okay, it's just a wee reminder, the first thing we're looking for is add and subtracts. Second things are sort of multiples. Third things are indices, so just put a wee squared there. Okay, and then watch out for barriers. These are our roots, our brackets, and our fractions. Okay, they can scupper us. So that's how we look at that. S equals all of 2. We want to leave V. Okay, the first step I'm going to do is just spin that around. So the V is on the left hand side. Then I'm going to ask you what's the first thing we move there. Okay, so we'll try to isolate the V. What would you say the first thing we move?
Would it be the 2?
Yep. Perfect. All right. Then what? We're removing everything outside the bracket. So everything outside, so the T's outside the bracket. So we're removing the need for the bracket by removing the T. So by removing the T, I remove the need for brackets. Okay, so I've moved the fraction across, okay, because that fraction is under, takes into account everything on top of that fraction. So I need to remove that bottom part, okay, to allow me to start moving the top of that fraction. Okay, and then what we're trying to leave is the V, and then it's 2s over t is one part of it, and then it's minus u. So that minus u doesn't go on top of that fraction. Okay, it's a separate aspect of it. Okay, so not That would be wrong. Okay, that minus U has to be separate. An honourable one. Right, make sure you copy that out correctly, okay? So what I've got underneath the root sign, so that root sign covers everything there. Okay, underneath that, I've got a fraction made up of t bracket n plus 2 on top of the fraction, and then divide by 4 on the bottom of the fraction. Okay. I want to make the subject of this n. Going to spin it round so it ends on the left hand side. Everything stays the same. What am I moving? Okay, so there's loads of barriers kicking about. What's the primary barrier? What do I need to move before I move anything else?
The square root.
Yep. Move the square root and it starts freeing it up, doesn't it? Square root becomes a squared. Okay. Then I've got a fraction. So I need to remove that part. That, and then I need to remove anything out with the brackets to access what's in the brackets. And then finally move my addition. Okay.
How come it becomes? Wait, hold on. I'm just trying to wrap my head around how it becomes a divide on the right hand side when normally it would become like a plus, like n, or like a plus, or like a minus n.
So this stage, oh, that's not my pen. This stage.
Yeah,
Okay, so t bracket n plus 2, that means c multiplied by everything in the bracket.
right.
So when I move the t,
Yep.
it's a multiple on the left, so it becomes a divide on the right.
Yep. Yeah, that's fine.
That's getting towards what you're getting in the exam. All right, you like throwing in a root sign or potentially. And I want to be the subject. All right, flip it round. Rid of the fraction because it's interfering with everything. Okay, and that releases that top line. Okay, now remember I'm isolating everything outside the bracket this time, so it's a squared multiplied by that bracket. So when I move that bracket across, the a squared stays there. And I'm dividing by everything in that bracket. So I can put the bracket in, or I can have it without the bracket. They both mean the same thing, both mathematically correct. All right, whatever you're most comfortable with, it doesn't matter. Looks the cleanest without the bracket, but as long as the 4D is divided by everything underneath that bracket. Okay. And then the last thing we move is that square, and it becomes a root.
Is that worth like 3 marks?
Yeah.
Yeah.
I'm going to give you one to try for a couple of minutes. And then we'll call it a night there. Breathe the X. We like then. Okay, first thing that moves across. Okay, is that root sign. Oh, sorry, let's change it side on. X plus 4 squared over 2p. All right, that's root sign just takes over the world, so let's get that rid of that. Becomes a squared. All right. Then we get rid of that fraction because it's interfering with everything above it. All right. So that x plus 4 squared equals 2p squared. Oh, sorry, 2py squared. Yeah. So far, so good. Okay. Now, what's involved? Well, I can't access anything inside that bracket until I remove everything outside it. What's affecting that bracket is that squared. All right, so once I remove that, take it over to the other side. I'm left with anything inside the bracket. Opposite of squaring something is rooting it. It becomes that. Okay, and then the last thing I need to move over. Be very careful, that 4 has to be outside the root sign. Okay. If you'd written like that, okay, with the root sign going over everything, that would be wrong. Okay, so the root sign is moved across before we've moved the 4, so the 4 comes out with that root sign. Okay, that would be that answer.
See how for the working, right? Like, see if you know how let me see, the second line of working,
Yep.
and it's like x plus 4 and the brackets 2, like all over 2p equals y squared. I missed that bit out and I just went straight to the line underneath that. Would that be a point missing in like
No.
marking?
No.
No, okay.
So where would your 3 marks be? No, as long as you probably would get a couple of marks there. All right, probably would be 3 marks in total. Maybe 4. I need to double check a couple of the past papers. I'll start next time with a couple of past paper questions and we'll look at the marking system
Okay.
for it. You wouldn't lose any marks for that because you're correct in what you've done.
Right.